So please, round of applause for Tejas Kumar, everyone.
Thank you. Thank you so much for having me. And hey, what an honor to just goof around on stage with Vitaly, who I consider a dear friend. Hi, everyone. I'm Tejas. That's pronounced like contagious. Since the lockdowns are over, I can say that again. And over the years, I've had the pleasure of working at a number of different companies or with a number of different companies in various capacities and just absolutely love what I do. And it's been an honor to build on the web for the past 20 years with learning from some of the greatest people I could call friends. And so today, I'm a developer relations engineer for GenAI at DataStax. But we're not here to talk about me today. We're here to talk about generating the future. That's the title of the talk. And if you read the abstract on the website, it won't be long until you recognize, okay, this is an AI talk. But I want to just set a context within which you're going to have this discussion, because the general vibe around AI lately is one of AI fatigue. I don't know about you. Anyone just tired of this AI stuff? Yeah, look, it's every hand in the room. It's not pleasant anymore. It's overhyped because the hype leads to valuations, which leads to large funding rounds, which leads to money, which leads to hypercapitalism, which leads to like, why are we doing this? And thank you. And what I want to do today is have a balanced, nuanced discussion with appropriate details of AI that give us a deeper understanding and maybe even appreciation for it, and highlight where it actually makes sense to use. To give a little bit more context, this was posted on X, formerly Twitter, recently, October 7th, by a friend of mine, Stephanie, who says, "Dear brands, companies, etc., I don't want or need AI injected into every single part of my life. I'm more likely to use your product if you're not shoving AI down my throat." And this, I feel like, is a well-reflected sentiment across this entire room. And my thesis that I want to give you today, right as we step into this discussion, is that AI and its features are like salt. You sprinkle a little bit in a meaningful way, and it can amplify flavor. It can give you taste. You use it respectfully, and you get beautiful results. If you pour salt on your food, you get sick. And so that is how we ought to use AI today. Okay? In my introduction, Vitaly called me an AI engineer. What is that? What does that even mean? I have, so far this year, have spoken at 16 different conferences. And at every conference, including this one, I take the opportunity to ask people around me, do you think you could be an AI engineer? Do you think you could identify as that? And most of the time, 9 out of 10 times, people will say, no, I don't think so. Then I say, why? Because I don't know linear algebra. A lot of this is gate-kept behind academia. I don't know how to train models. I don't know what fine-tuning is. Does that resonate with any of you here when I asked you if you could be an AI engineer? Yeah, show me your hands. Yeah, okay, that's almost everyone again. The truth is, they're entirely different beasts. You don't need to know Python. You don't need to know machine learning. AI engineering, machine learning engineering are very, very different. And to show you this with a little bit more detail, I'd point to my friend Swix, aka Sean Wang, who owns Latent Space. It's a blog and a newsletter and a podcast. And in it, he defines what AI engineering is, probably in the most clear way. And it's this. You see this diagram here? And you've got data, which is research constrained, and you've got products on the other end of the spectrum. And what you can see is machine learning research comes before machine learning engineering, which is training models and so on. And you've got this big dividing line down the middle, which is the API. And after the API, you've got where the AI engineer falls, right? And then after the AI engineer, you've got the full stack engineer. What this means is that if you're a full stack engineer, then AI is but one of the tools, one of the elements of your stack. And oftentimes, probably in the most crude, top contour way, to be an AI engineer is to interact with an API that abstracts on top of a machine learning model. It is not training a machine learning model. It is not doing research on machine learning. It is far from academic. It's just talking to an API. In the most crude sense, if you can call a function like fetch in JavaScript and talk to OpenAI, congratulations, you're an AI engineer. You might think, whoa, this is strange. But I want to draw your attention to the bottom of this page where there's this quote which says, in numbers, there's probably going to be significantly more AI engineers than there are machine learning or large language model engineers. One can be quite successful in this role without, pay attention to this last piece, without ever training anything. And it's also important to note who says this, right? This is Andrej Karpathy. For those of you who don't know him, former VP of self-driving at Tesla, co-founder of OpenAI, chief scientist at OpenAI. Not chief scientist, was the head of AI or something like this. But he had an instrumental role in creating ChatGPT and the GPT models. In fact, now is a YouTuber who has courses on like, here's how you make GPT-2 just for free. That's on YouTube, multiple hours. You can go watch that. And so if there's anyone qualified to make such a claim, it's Andrej Karpathy. Okay? And so this is the working definition of AI engineering. And this is not just my opinion, it's Andrej's, but also I run a podcast where I talk to experts in AI, experts like Harper Carroll, who has studied AI for 10 years at Stanford University, says the same thing. You don't need to know machine learning to do AI engineering. So if I ask you again, do you think you could maybe, hypothetically, possibly, one day be an AI engineer? I'm hoping that this becomes more accessible. That's the point of this. And I see a lot of you nodding, so I'm glad that lands. Okay, let's talk about AI. What is AI? You see, like when Google does the keynote, and this is no disparity to Google at all, but you've seen the memes, right, where people summarize the Google I/O keynote and Satya just says I/O, 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 sorry, AI, 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 122 times. What does that actually mean? There's many types of artificial intelligence. If we just take the semantics of an artificial intelligence, then we arrive at things that look intelligent, period. What looks intelligent? Well, logic gates. If you've played Pac-Man, right, the Pac-Man rule, and you eat the cherries, then the ghosts that previously approached you to eat you avoid you. They turn blue. I don't know if you remember your Pac-Man lore. But that's an example of rule-based AI. It simulates intelligence. These ghosts avoid you. They're intelligent. The only difference is the rules of avoid Pac-Man or eat Pac-Man are known by the developers ahead of time, and the if statements are written. But that, indeed, is an example of rule-based artificial intelligence. Rule-based meaning the rules are known ahead of time. There's predictive models, like the autocomplete on your phone, which is just a big Markov chain. A Markov chain is a statistical model that calculates the next most likely state based on the current state. And so if you use the autocomplete on your phone, above your keys, you have these word suggestions. Have you played this game where you just tap the middle one constantly? That's just a big Markov chain. And the problem with Markov chains is what's called the Markov property, which is it's memoryless, meaning you take the current word and you predict the next word, but you don't have memory of previous words, and therefore you end up with nonsense sentences when you tap the keyboard repeatedly. That's predictive AI. It is indeed AI, but it's a statistical model. Deep learning is a whole different beast, and this is where we find the hype, right? Deep learning literally models the brain through neural networks. We can go into a lot of detail here, but we don't have the time for it. The gist is, you've got something that looks like a human brain where you have an input layer. This is you giving a picture of like something maybe containing a dog. And there's these hidden layers which literally just model neurons and the connections between them in the brain. And you have your output layer. And so the machine, the computer, algorithmically figures out the rules. It's not that a developer writes the rules, it's that the machine figures out the rules. The reason we're going here, and again, you don't need to know any of this to be an AI engineer, but we're setting the basis for what AI actually is, specifically generative AI. So you have these neural networks. The architecture is very simple. Input, bunch of hidden layers that run algorithms to arrive at probabilities, and then the output layer. Inside these layers are called architectures. And there are many different kinds of architectures that simulate attention. The one behind the GPT models comes out of a paper published by Google titled "Attention is All You Need." And this paper, it's not a long paper, it's not a difficult paper, it's available on the internet. I highly recommend reading it. What they talk about in this paper, mostly Google brain scientists, is that and Google brain scientists, they're not brain scientists, the thing's called Google Brain, they found a way through software, through programming, to algorithmically model attention. Not just attention, but multi-headed attention, where instead of Markov chains reflecting on the current state to predict the next one, they can, with software, algorithmically pay attention to a word or an input token and the surrounding context around it. And it's not just one word in its context, but it's all words and all contexts in parallel. This is part of the training process, and this happens in the model architecture. This is called the transformers architecture, which gave birth to what is known as generative AI. And this is the overhyped thing that none of us like anymore. Okay? Generative AI, or Gen AI. And the big question that seems to be asked, a lot of us seem to be asking, including like people asked me this at the party last night, was do I have a future? Someone asked me that this morning. Nate over here asked me like, hey, give me job security because am I going to be? I'm a UX designer. Am I going to be used? The truth of it, and what I'm going to convince you of through the remainder of this presentation, is absolutely you'll probably have job security if you're working in some type of front-end or front-end adjacent technology like UX. And the reason is models are like cheap imitations of humans, right? Like this is a person looking into a mirror and seeing something that's not them. This is what I feel like when I talk to ChatGPT. It's not human. There are many problems with generative AI. Can we think of some of them? And these problems, I will submit to you later, are by design. Problem number one, they're static in their knowledge. Like, by knowledge, we mean things that they've learned from large corpuses of text. So if you think about a model like GPT 3.5 Turbo or GPT-4, GPT-4o, has learned its last thing as of April 2023. We're in October 2024. So you can't get up-to-date information. Problem number two, hallucinations. I mean, we have Google AI overview here in the US, and you've probably seen the memes, right? Where people ask Google, hey, how many cigarettes should a pregnant woman smoke every day? The answer is 0, in case you're curious. Also, not just for pregnant women, for everyone, but in any case, Google responded to this with a pregnant woman should smoke 3 to 5 cigarettes per day. And the reason for this is because the training data contained jokes and satire. But of course, the large language model doesn't know that. Gemini doesn't know that. And so you have these weird scenarios where you actually have dangerous misinformation. Problem number three, the length of context is finite. Now, Gemini, the model from Google, boasts the largest, what they're calling context window of all time, which is 2 million tokens, where a token is equivalent to 1 English word, roughly. Okay? But have you ever thought about how long 2 million words is? It's in the grand context of your life where you want like a personal assistant like Jarvis, this is really nothing. And as you start to approach the maxima of this context length, you just start to get useless or nonsensical information. Finally, I think the biggest problem is it's just not human. Like we are highly fundamental, irrational beings. And that's a feature, not a bug. Our ability to be creative and hallucinate, but in a different way than the machines, and fall in love and tell stories, this is something that Gen AI will never ever be able to replicate. Even though we can now model like vocal emotion. Some of you may have seen ChatGPT Advanced Voice. We can't go much further than that. So I want to talk to you about AI engineering and a solution to all of these problems, and we'll look at how we can actually do better through quality UX and design work. The main thing I want to show you is a technique called RAG. Anyone familiar with RAG? RAG solves, okay, like 5 of you, this is great. RAG solves all of these problems. And RAG is the reason those of us who do work on the front end, even as UX or designers, are needed and will be needed. Because here's the thing, GPT-3, when it came out, as a large language model, nobody cared. Absolutely. OpenAI shipped it, and then nothing happened. And then they put a front end in front of it that looked like a chat interface, and then it took over the world. But if it wasn't for the front end engineering, the UX of this thing, ChatGPT would be nothing. Okay? And so RAG is building on top of this front end. RAG stands for Retrieval Augmented Generation, which just means you get some context that the model will not have, like today's weather, like an exchange rate, like we'll look at some examples. So you retrieve some up-to-date information past its knowledge cutoff that cannot be hallucinated because you've retrieved it from a reliable source. And then you use that retrieved information to augment, aka change, the generated output. Is that clear? And so it's exactly what at its core, it manifests in prompt engineering. So you retrieve some real context and you use it to change the output of the LLM just by putting it in your prompt. RAG typically has these elements, so you actually need data, like up-to-date authoritative data. You need an embeddings machine learning model. What does this mean? It's a specialized machine learning model that can take natural language and embed it in dimensional space. What is dimensional space? Well, let's do it right now. We have 3 dimensions, right? Dimension 1, dimension 2, dimension 3, depth, okay? And so if we embed the meaning of a word in dimensional space, we could say words like cats and dogs are over here because they're close, and words like iPhone are over here because it's different than cats and dogs. And so we can put things in space. That's what these models do. They take natural language, put them in space. Number 3, these lists of numbers, these embeddings are vectors. They're mathematical vectors. They're big lists of numbers. You need a vector store. You need somewhere to store them. You combine these elements together, you can create some really reliable RAG applications. But instead of like telling you, let me just show you some RAG in practice in about 20 minutes. Let's look at RAG in practice. Example number 1, ChatGPT. ChatGPT doesn't know today's weather. But if we ask, what's the weather in Berlin? Then it will perform RAG. It's literally, it's retrieving and using that retrieved data to augment result. This is RAG. ChatGPT itself needs RAG because the underlying model doesn't know. It has not been trained on this. That's a front-end UX feature that makes ChatGPT useful, that the model alone cannot do. Okay, so that's value right there. RAG example number 2, I have a podcast. It's people love it, but every episode is very long. It's like 2 hours, long form, and people go like, I don't have the time for this. I just want to know about resource hints. And so I built a RAG-style podcast search where it's just like, tell me about resource hints, which is a performance primitive in web engineering. And it will search every conversation we've ever had, and we say we discussed resource hints at this time with Dan Shapir. I don't know, some of you may know who he is. And if we click on the timestamp, we go exactly to...
So I don't know how familiar you were with resource hints.
And he just continues, right? And so that's RAG. You see the intersection here of UX and AI. This whole thing, shout out Josh Como, helped me with the UX of this, thank you. This whole thing, making the text shiny and saying like, click on it, and the whole sparkly emoji, all of this comes together to use AI and UX in a meaningful way for users, okay? Number 3, Luke's talk yesterday, big RAG app. Absolutely love Ask Luke. I love that he alluded to this as well. He gives you follow-up questions. And this whole thing on Luke's website is just a big RAG app. Similar to Perplexity. Vitaly mentioned Perplexity yesterday. I haven't Googled the thing in so long, he said, after the last talk. This is Perplexity. Where is SmashingConf New York 2024? And Perplexity will search the internet, find the location of SmashingConf New York, summarize and synthesize the information, and then say it will take place at New World Stages in Manhattan. Look at that, brilliant. And it cites the sources because it just like searched the internet. This is all just RAG and UX plus AI, okay? You even get the address, the date, and the cool thing about Perplexity is you can choose any large language model you want, because here's the deal, the model doesn't matter. Well, it does matter a little bit to generate text, but what matters more than that is the front end and the UX. I hope I've convinced you of this fact. But now some of you might be thinking, okay, this is cool, but how do I build this? The whole reason I do what I do is to make all of this accessible to everybody. How can you build a RAG application? Sure, you can fetch from some API and so on, but I want to really cement how RAG works in your mind through a diagram. At DataStax, we make a diagramming tool, and so I'm going to use my thing to show you how RAG actually works in practice. It's called Langflow. Of course, I need to log in. But let me show you this thing, because I think it's the clearest way to explain RAG to someone, and RAG's intersection with prompt engineering and more. So if I sign in, and what I'm going to do is I'm going to switch organization. All of this should have been done ahead of time. I'm so sorry. This is so low quality. This is probably the worst talk at the conference. Anyway, please tell Vitaly. Anyway, so let's make a new project. It's a blank flow, and we're going to model RAG here. So if you look at any chat application, you've got a chat input. You've got a large language model. Let's use the one from OpenAI. And you can use any. You can use even Ollama here, which is, Ollama is a way to run a large language model locally. If we had more time, we'd get into that. And then you have a chat output. This is like your basic quintessential chat with an LLM application. And we'll chat with GPT 3.5 Turbo. So I've wired everything up. This is not RAG. This is just talking to an AI. And if I go, which movie won the Oscar for Best Picture in 2024, right? In theory, GPT 3.5 is not going to know this because it's past its training date. And this is what it says. I'm sorry, but I don't know, which is kind of nice that it does that instead of making something up. But we can fix this with RAG. So at using DataStax's database, I have loaded every Oscar winner into a database. So what I'm going to do, between the chat input and the large language model, I'm going to introduce some RAG steps. I'm going to go to my database, my vector store. We talked about what that is. And I'm going to say, I want you to talk to this database with the Oscars collection. And I'm going to grab an embeddings model. We talked about an embeddings model, right? Which is just a way to convert natural language into numbers. So I'm going to get OpenAI embeddings. And I'm just going to convert these. I'm just going to connect this over here. And I'm going to connect this chat input to the search input on my database. Now, the database is going to send me a bunch of records. So I need some way to parse this. Just grab the parse data. And that's going to take the data from the search results. Can you see that? It's going to take the search results from my database and turn it into text, okay? Now that this is all turned into text, I'm going to construct and engineer a prompt. So how do we do that? We have prompts. I'll just grab a prompt, just like that. And there's nowhere I can plug this into. So what I'm going to do is, this is the most quintessential RAG prompt you can imagine. Given the context, and we'll say context, answer the question. And I'm creating variables in my prompt here, just like that. And so now, I'm going to check and save this. And now I've got these things I can plug into. So context comes from the database, so I'm just going to draw that line. And the input, the chat input, goes as the question. Finally, I get a cohesive prompt that I pass as input. Okay, so I've just created like a little RAG flow. What that means is I just added a search step here, you know? And so now, if I go and run that query again, it will actually read the data from my database, put that in the prompt, send it to OpenAI, and we have, look at that. You just solved all the problems. Yeah, thank you. We solved all the problems of hallucination, finite context length, knowledge cutoff, all of it. And we could even do more. We could be like, tell me more about the 2024 Oscars. And I want you to see that we've given a more human touch by curating the information we've given to the large language model. Suddenly it knows all about the Oscars. Oppenheimer got 7, Best Director for Nolan. It had no idea about any of this before. It's very important to state we're not training a new model here. We're not touching the model at all. We're just giving it more context. Is that clear? This is RAG. This is what we saw in ChatGPT, in my website, in Luke's website. This is the technique. And it's all modeled beautifully for you with this flow. These are the steps. So you have an input, an embeddings model, a vector database. You parse its output, construct a prompt, and then give it to the LLM, right? That's it. I think, though, we can do a little bit better. Let me see. And so what we can do even better is talk about UX, because what I just showed you was just a big chatbot. And I don't know about you, I'm tired about chatbots. I like this dude. I hate chatbots. And I think this is a UX conference. I beg for better UX than a chatbot. I'm like, what can we do that's better than a chatbot? So I want to introduce you in what little time we have left to generative UI. Not generative AI, but generative UI. Have you all seen this? This is what I want to spend some time talking about. And instead of talking about it, let me just show you. So I don't know about you, but when I search for a movie to watch, I don't think about the exact title, especially not after a long week. I'm not like, yes, I want to watch Journey to the Center of the Earth. I'm not this kind of person. I'm more like, you know what I feel like? I watch a romantic comedy. Maybe one set in Europe. This is how I think, you know? And so, unfortunately, the internet is not made for people like me. If I go on Netflix, which I love Netflix, to be fair, and I literally just type that query, romantic comedies in Europe. Look at this. Your search did not have any matches. And the first suggestion is try different keywords. And that's because until the age of generative AI, this was the best we could do. Keyword matching algorithms. But now that we can capture not just the words, but the semantic meaning, aka the subjective vibe of the word, we can match on sentiment using Gen AI. So we can do better. In fact, we do better. My job at DataStax is 50% research, 50% teaching. As part of this is the teaching mode, by the way, hi. As part of the research, I thought we could do better. So I built an app that is what I consider to be superior movie search. It's called Movies++, and the UI looks very similar to Netflix, but it works slightly differently in that I can type something like, let's try that again, romantic comedies in Europe, and what's going to happen is it's going to ask Langflow. So the tool we just looked at is Langflow, and it's going to give me this, which is kind of lame, and it still kind of looks like a chatbot, but this is like step 0. We can do better, and this is what better looks like. What might this look like as UI? And I'm going to send that over. And you see this? This is generative UI. Absolutely brilliant. And it's not just some server-rendered, non-interactive stuff. It's actually, beautiful. It shows me with detail what I'm mousing over. In fact, I can click on it, and I'm taken to more details on the movie database. But I could also just go to a different page in my application. This is what I wanted Netflix to give me. Like I type in a search query, and I get that. I get like UI, right? We could do something maybe even better. We could say, show me the trailer for Notting Hill. I don't know if I'm gonna like this movie, and so it's gonna do that. And actually, if all goes well, like show me, yeah, this is the actual trailer for Notting Hill. I'm not gonna turn on sound. I'll save you, but that's the trailer right there. I could say, where can I watch movies? This is endless, right? Today, and like a literal map of where it's walking distance from like New World Stages where we are right now. Absolutely bananas. And so this is what I want. This is sure, it still looks like a chatbot, but I want you to extrapolate that this is not going to be a user of your application typing these, but it's going to be the developer. Does that make sense? Like if you go on Amazon.com, you have product recommendations. You know, like it's got UI, it's got a picture and a name and a link and a price. That can be generated with AI without a user typing in a prompt. It's more your developers are like, here's the user account, now generate some UI. And it just does that, and you serve that to users. This is possible through React server components because these are actually being generated by the large language model, weird, and sent over the network. We can, if you want to geek out about the technical details of that, we can. But I want to land with one final thing. This is actually very practical for user support. Every time I go to support on a website, and I'm given a chatbot, I hate it. The first thing I look for is like, where's the human? How do I talk to a human? And that's just because the chatbots are just not capable. But what if they were? For example, imagine, let's shift context a little bit. Imagine this is now a support bot. I could say something like, I forgot my password. Okay, we're not doing a movie thing anymore. This is just a proof of concept. And now, instead of like, how to reset your password, I just get a form like this. This is what I want. And I just type in my new password. And I click this, and it's done. This is whoa. No, but this is utility, right? This is more than just a useless chatbot. In fact, it's a very useful chatbot because it just, as a user, I just type what I want and I get it instantly. As a developer, I can use it to generate portions of my application. Let's quickly talk about how this is built, and we'll land the plane. So I want to show you some code. And what I want to show you, what I'll preface the code with is this. As a human being with a brain, hopefully, I know the limits of my knowledge. Like if you ask me to stand up here and multiply 8 prime numbers together and give you the result, I'm going to be like, no, I don't know. But what I do know is that there is a tool available that I can reach for and use, a calculator. Large language models have this exact capability. They're able, like as you saw when I queried GPT and asked for the Oscar winners before RAG, it said, I don't have access to that. As per my knowledge cutoff, I don't know. But you have the ability as a developer to specify tools. Like here are a bunch of tools, use them when you feel like it, believe it or not. And they can use them. And the tools are just functions in programming code. So with that, I want to show you the tools that give us the movie posters and the trailers and things like that. To do so, let's use Cursor. Why not? Anyone using Cursor? I'm glad you said, oh, just one person? Nice. So it's this file. This is the code that gives us that. So what we're looking at here is the Vercel AI SDK. You don't need to use the Vercel AI SDK. You can do this with just OpenAI. You can do this with whatever you want. But I used to work at Vercel, so I'm a little bit biased. This is what I want to draw your attention to. Tools. you pass in a configuration object, tools, and you've got key value pairs. And a single tool, for example, show trailer or get movies, is actually, let's do show map. It's the simplest one. You've got 3 parameters, a description, and the large language model reads this, therefore knows when to use the tool. When a user asks for a location where to watch movies, use this tool. It then looks at the parameters object, and you could specify whatever you want here, something like this, which is a Zod validation schema. And finally, you've got the generate function, which is a generator, literally. The star means it's a generator, and it can do some really great things because it can yield to the user when it's actually making a query. And generate is you can just return a component. That's it. With forgot password, I think is really cool because it's the forgot password tool. When the user says they forgot their password, use this. And to generate, you just return a React component. And this isn't coupled to React. So if you want to use web components, if you want to use Vue, if you want to use Svelte, whatever, it doesn't matter. A function that returns UI is just a component, and an LLM could call it. This is all the magic that's happening here. Okay, and let's look inside forgot password. What is forgot password? It's literally just HTML. With Tailwind, I'm sorry, I know we hate Tailwind. I'll die on that hill though. And so it's just UI, and it can be literally anything. We could be like, oh, poor baby. I don't know. And let's just try that. Let's say I forgot my password, you know. This is, and I want to show you, this is not like some video. This actually, oh, look at that. That's so cool. The cool thing about this is, I should make the large language model say Cry Me a River. The cool thing about this, though, is that large language models, their output is usually non-deterministic, right? Like you send a prompt to a large language model, and even if it's the same prompt 10 times, you get back usually 10 different answers. It's not deterministic. With function calling and returning your UI components, you add a layer of determinism. You will always get back the same forgot password component. Always. And the only thing that changes is the input properties, meaning the parameters, if your component has props. This way, you bring some control to the otherwise chaotic world of large language models, okay? Let's summarize. We entered into a discussion on Gen AI, which is overhyped, and we're all tired. We're tired because it's overused. My intention today was manifold. One, I wanted to make it accessible to you. I wanted to show you this is a space that you can play in without being some Python expert with a master's in machine learning. In fact, you don't need to know anything about machine learning. Just call an API, start there. I hope I've made that accessible to you. Number two, I hope I've explained some of the problems in the space, like hallucinations and finite context, and how you can get over them with RAG. RAG is an extremely powerful technique to bring real-world context and human-verified context into the generated output of machines, removing some of the nonsense that they can hallucinate. What was that? Number three is chatbots suck, frankly. And we can do better through generating actual UI components, not in response to user queries like we saw with my movies thing, but even ahead of time. The developers can generate UI using a large language model and just serve it over the wire to users. I hope all of that has become very clear. I've got 2 minutes left, and I want to spend these last 2 minutes actually talking about some hype that I get the impression that we're all cooked. And this is, look, just humor me a little bit, because like generating the future is the title of the talk. Let's generate some stuff, because I was very motivated by the first talk where he made Wordle. Have you all heard of V0? No? V0.dev. Here, look, make me Wordle with pure HTML and CSS only, using the pattern input attribute. The correct word is, what's a 5-letter word? Input. And just do it. And so I send this prompt off, and this is absolutely bananas. This one actually does scare me. And this is not, look at that, that's absolutely, and it will do it. And then when it's done generating, it will tell you how to use it. Pure CSS, no JavaScript at all. And it's using the pattern property here for validating exactly my word. I mean, there we go, Wordle clone. Except a single, and so it tells you what's wrong, definitely. And it's not okay, but it does, at the end, it's an iterative process, so we can say, like, change this and fix that, but it's kind of bananas that this just exists without any JavaScript as well. The validation doesn't work. Validation. Anyway, so this is something I could play with for hours, and in the end, it'll probably fix it. But the fact that you can go from 0 to this as rapidly kind of blows my mind. And this is something I'm paying attention to very closely. I think we're still not fully cooked, so to speak, because you can see that there's human intervention needed. But I think, as I mentioned earlier, when it comes to techniques like RAG, we always need augmentation by humans, therefore we will never be obsolete. And with that, I want to extend really a heartfelt thank you for your time and attention today. Thanks so much.
Oh, here we go. Always a path to travel. Thank you so much, Tejas, Jeremy, for your conversation.
Yes.
I think for me it's really kind of impressive because you also see some companies doing this sort of layering where they bring in a human as a kind of part of a process.
Yeah.
Like, for example, you see situations where you have machine-generated output. Like, imagine somebody is asking a particular question to, like, a chat GPT or something, and so the first response will be generated by AI. But then, if it's a critical, like mission-critical question or task, or like finance or something similar, then there would be a human who would be verifying if that response is correct or not, if it's representative for a kind of type of queries or so. And then if it's vetted basically by the human, then this is a style or the type of answers that will be kind of showed to the user in the end. And I'm wondering at this point, we're kind of hitting the bottleneck, if you like, right? Are we? Because if you're looking at some really dense, complex applications, you kind of need to involve a person. Person or human can also make mistakes, though, right? So how do you see that? I mean, I'm really applauding the effort that we need to, I mean,
verify.
especially, we kind of need to be in a position where we're vetting what is being produced, especially if it has implications. But how do we make it all work without, overcomplicating, over-engineering the code, or investing too much time and effort into human checks?
Yeah, that's a good question. Human checks are actually starting to disappear in some fields already. For example, a big part of training a model is performing what's called evals, where you have validation data that once you get a finished model, actually during the training process, you can give some validation data. This is data that the machine learning model has never seen, and test what its inference is on this data. And this used to be done with what's called a human in the loop, meaning you just watch the rate of errors go down over time. This is changing to where now there's a methodology called LLM as judge, where before a human verifies that the validation is actually appropriate, a large language model will do that. So think of it this way. You're trying to train a model, and you have inputs and outputs, and the model generates outputs for inputs it's never seen. You have a step before a human looks at it where you take those outputs that are novel and give them to GPT-4. And you're like, GPT-4, does this look good? And GPT-4 will pass or fail that. And if it fails, then a human is requested. But if it's good enough, then no human is not. So this is already happening. Like, there's a company called OpenPipe that a lot of the evals are fully LLM as judge. And they're watching the need for human evals go down significantly. So that's one way, is to just use an LLM. There's also agentic workflows like this. Like, I have a friend, Zach, forget his last name, he's gonna kill me. Anyway, he works at ByteDance on TikTok. And he's got these stockbroker AIs, where they say, buy this, sell that. But before he gets pinged, he's got lower class models like GPT 3.5, watching stock prices and making recommendations. But before he gets pinged, he has them send their recommendation to a larger one, like GPT-4. Does this make sense? Okay, now ping me. And so he gets pinged when it's the right time to buy, but it's vetted by like layers of LLMs
Right.
before.
And is it then a specific language model that's focused on that domain, or is it just a general one? Like
That's a really good question. For the vast majority of people, unfortunately, it's a large general model, but this is not usually the best. The better approach is to have smaller specialized models. I believe this was a discussion after
we had it
Luke's talk yesterday. Yeah, that's the future, 100%, is large language models are kind of useless at specialized tasks. This is also why you made the joke earlier, right? Full stack engineers often tend to struggle with either front end or back end. It's exactly the same. You can't have such broad generalization that translates to excellence in specialization. And so large language models aren't very useful for specialized tasks. And this is where fine-tuning your own specialized model comes into play. For example, I showcased my podcast search earlier. That is 100% my own model. It just knows, because it's important to generate the right HTML with the shiny text. GPT-4o can do that maybe 50% of the time, but I needed a model that can do it 100% of the time. And so I created my own. Also, it's a matter of cost. A smaller model costs way less to host and to perform inference on. And so, yeah, this is 100% the future.
There is a question on, in our company, we want to automate many of the existing processes and train AI on our huge knowledge base for financial history and transactions. How much time does it take these days to train a model well? And how do you know that it's actually trained well? And also, how expensive is it actually?
That's a good 3 questions.
Yeah, 3 questions. Yeah.
I don't think anyone needs to train. I'd say before you embark on training a model, it's better to see how far you can get with RAG, because the models that exist are very capable, right? And the only thing missing really is access to quality information. There's a great book titled Developing Data-Intensive Applications, where they really teach you that garbage in, garbage out. And so if you can get not garbage in, if you can get quality in through your prompt, then you'll probably get some good inference. So I think you have to really, really, really prove beyond a shadow of a doubt that an existing large language model is bad given the right prompt. Then start training something. Training something is obviously orders of magnitude more expensive in both the domains of time and money. Time because the algorithms need like a long time to run, depending on your data set.
Like months? Or
depends. So depends on the number of parameters. So remember, we talked about model architecture. There's an input layer, there's an output layer, and there's these hidden layers. The hidden layers contain neurons, so to speak. Each neuron you can think of as a parameter. It's a dial which you turn slightly to arrive at the right output. GPT-4 has, I think, 600 billion parameters. The more parameters, the more training time. And GPT-4, as far as I know, is a fine-tune of GPT-3. In any case, if you have a small model, it's not going to take long. My podcast model has 7 billion parameters, trains in literally hours on my Apple M1. Because it's a fine-tune of Mistral 7B. So it really depends. But it's complicated in time, but also money. It's very expensive. One, because you need personnel costs, like you need somebody to do the evaluations. They tell you that training a model is the full end-to-end process. It's not. Once you have a trained model, you need to verify that it works. And that's expensive in terms of personnel costs. Someone has to like prompt it and make sure it's not going to fail. And then there's the added risk of something inaccurate, right? So it's way too risky and expensive to actually train something. So for this question, I'd say find an open source model, run it locally, and then just construct the best prompts of your life, and this will probably get you very far.
So would you say that the crux of it all is becoming more this way of designing good prompts?
Yes.
Is it like a prompt engineering really becoming sort of a major part of what we do? Because I can imagine you have, let's say, a good UI. You have, instead of typing it all in, you have a couple of buttons. And so you click on one of the buttons, and then it has one of the prompts being sent out, right? That's it, really. And so you really have to be very careful about the parameters that you include, the templating for prompts and things like that. So this is really everything then? Like, no, not everything, but this is probably the most important thing that you need to do when it comes to this communication.
Yeah, because garbage in, garbage out. It's the same. You're asking me very high quality questions. And so I can give you high quality answers. But if you ask me broad, bad questions, then I'm not going to, it's the same. It just models interaction.
Well, there were a couple of people who asked, where can I get the Movies Plus application, please?
It's not an application, it's just a research project, but you can find it on GitHub, fork it, make it a product if you want. It's on github.com/datastacks/movies_plus_plus, PLUS, not plus sign.
Okay. Do you have any opinion on any of the existing models? How do we choose the right one?
Great question. Depends. It depends. This is the answer, right? It depends on cost. For example, if I'm a billionaire, I'll go find the most expensive model and use it. But I'm not. I wish I was. What I would do is, and also actually not even if I was a billionaire, right? Because there's environmental considerations. This stuff is killing the planet. We need to talk about that. And so I would, thank you. So I would start with the smallest model. See how I go. What does see how I go mean? It means I will send it a bunch of prompts in an automated framework, so not just me typing stuff. I will create a proper testing methodology, a benchmarking system, send some prompts, see how it performs, and then scale up from there. There's also considerations for, do you want to share your data with OpenAI? Now, OpenAI will offer you the chance to opt out of them seeing your data and reusing that for training, but it's hidden in settings, and you may not find it unless you look for it, right? And so what I tend to do, also to manage costs, but also privacy, is there's a tool called Ollama, which is, I believe it was founded by people who were co-founders of Docker. And it's like Docker, but for LLMs. So it abstracts away the infrastructure required to run an LLM. And how it works is it's a command line tool where you just say Ollama run model name, that's an open source model, and it just runs it on any hardware. And in the cloud on like an EKS cluster, a Kubernetes cluster or whatever. So it can do inference for you. And so with this plus an open source model like Llama 3.1b, Mistral 7b. Mistral 7b is an underrated model. It's a great model. If you want function calling, like we talked about to show movie posters, there's a model called Mistral 8x22b that has support for function calling. I use that. And so open source models plus Ollama is a good place to start for privacy-centric things. And also, not feeding the sort of hyper-capitalist machine.
Excellent. Maybe just one final question by Nathan. Of course, we have a lot more questions, but I'm not sure that he'll be also maybe available for questions outside after the next session. Nathan is wondering, generative UI sounds very cool, but how do we ensure it generates good code that does not create all the problems that junior developers run into? Like form validation, correct API interactions, accessible components. Just to finish the question, thinking about the scary people, how do we scary people?
Do you mean like Satan?
I'm not sure. But how do we ensure that generative UI does not get exploited to create a malicious code?
Yeah, I think this is probably, I could have done, thank you for the feedback on my talk, because I could have done a better job showing you. With generative UI, it's not that the components are created on the fly by large language models. I had this thing where I mentioned it brings determinism to the large language models. The components themselves are components I wrote. I showed you the code when I went into the forgot password, how it was just a form. I wrote that component. And so what does the LLM actually do is it creates the input parameters, or the props if you speak React. It creates the props for the component. So if you think about like a blog post, you've got a post component, title, date, content, or children, right? The component itself, structurally, I wrote. But the props, the title, the date, the content, those input parameters are generated by the LLM. So in terms of recreating code that can frustrate your team, the LLM will never do that because the LLM is not writing any code. It's just calling my function with different parameters.
Okay, well, I think that you have a lot of passion for AI and you're very excited about like what is happening next. Is there anything that you think or you wish we had in this AI world now?
So much.
With -1 minute.
I'm sorry. Yeah, I live in Germany. So when I came to the U.S., I spoke to somebody, and they said, "Where are you based?" I said, "Germany," and they said, "Ah, you guys, you regulate, you don't innovate." That's what they said, and it hurt me to hear that, but I think we need to find the right balance between innovation and regulation around data privacy, data stewardship, environmental constraints, and energy requirements. I wish we had that. I think the US is too much towards the side of innovate at all costs. And I think Europe is too much towards the side of we need to be safe and not do anything. And if we all, as a global economy, can find the middle, that's what I wish we had.
Well, thank you so much for being here, Tejas. Thank you so much.
Thank you.